Good to go. All right, we'll go and get started. There might be some other folks come filtering in, but that's no problem. They can come join us. I'm going to talk today about the advantages of writing tests first using test-driven development. And I'm Craig Atkinson. I'm a chief technologist here at Object Partners. A little bit about me. I've been doing TDD for the past 7 years on a variety of projects, everything from embedded C technologies up through the web we use today with Ruby, Rails, and Angular. So we're going to talk about today. First, a quick introduction to what I mean when I talk about test-driven development. Then go through the 5 advantages that I've outlined of writing your test first. Then a quick guide on how to get started with test-driven development. And then we'll run through some examples. A couple of code examples, one, then kind of a high-level walkthrough of what we might do in our day-to-day jobs as developers. We're adding a feature to an application. All right, so first off, what do I mean when I talk about writing tests first with TDD? So I'll contrast TDD with kind of the standard way that we develop. So in the usual way, we go in, we get our task, we write our code and implement it, so write our production code. Then we go and we start up the application, do whatever data setup we need, and we manually verify the code works correctly. And then after that, we write some automated tests. We run these tests, and generally they're going to pass because we've already done our manual verification, and we know the code works correctly. And then after that, we're done. We check it in and move on to the next task. So how is it different if you do TDD? So it's a slight change, but it is a critical change. Before writing any code, I write my automated tests. So this is before I've written maybe any classes. Perhaps I've written some interfaces or some code like that. Before I write any kind of logic, I write my automated tests. So to do this, I have to start thinking about the design of the code to be able to test it. And it feels a little bit weird to write tests for code that doesn't exist yet the first few times you do it. It takes getting used to. But then, now that I have my tests, I run them and they're going to fail because I haven't written any of the code they're supposed to test yet. And this fact that I run them here and they fail feels a little strange, but a little bit later I'll talk into why this is very helpful. And now I write my code, write the production code to make either my bug work or my new feature work correctly. And I have these tests already, so to know when I'm done, to know that my code works, all I have to do is run them. And they pass and I'm good to go. And now I can check that in and move on to the next ticket. That is a great question. There's been a lot of talk, especially the recent is TDD dead webinars and so forth, about they kind of devolve into, oh, is unit testing good or is unit testing bad? I do TDD at all levels. So I do browser functional testing, and I use Grails for a backend. So in the Grails world, you have integration tests also that connect to the database, and then unit tests that don't talk to the database, just verify logic. So I do TDD with all those different levels, and including JavaScript unit tests as well. And the last example that I do about the new feature to a web app, I'll talk about kind of the cycle that we go through to do that. That's a great question. So this is a standard terminology for TDD, the red-green refactor loop. So this red is when I wrote my failing tests, ran them, watched them fail. Green is where I wrote my production code to make the test pass, ran them, they passed. And now I have a safety net where I can go back and clean up my code if needed. If I find out, hey, there's some areas here that are common, I can extract them out into a method. Then I can do this refactor step. So I can clean up my code before I check it in so I don't start building up tech debt over time. I can hopefully weed that out. And if it turns out that I'm working in an existing code base where there are other opportunities to clean things up, maybe not things that I necessarily wrote in this ticket, because I have my safety net of tests, I can do that. And I can keep running this cycle until my task is complete. All right, so what are the 5 advantages about writing test development first? The first one is that the tests have value longer. So what do I mean by that? In the traditional way, when we write our tests afterwards, generally they're going to pass. We've already manually verified they work. So my tests are really only worthwhile in the future if I happen to update that code or somebody else is maintaining it and they need to tweak it. So then they know they didn't break anything that used to work before. But that could be later on in the future, which depending on, we deal with really tight timelines in our projects, depending on how much time pressure there is, it can be tempting to just say, okay, our tests are only going to be valuable later. Let's just push that off until the very end of the project, or potentially just not do it at all. because they don't have value for a long time. But when I write the test first, it has value for me immediately in the dev cycle I'm already in. So I can use that test to verify my code works immediately. So not only is it helpful in the future, whenever the code might be updated, it's helpful to me today. Second advantage is that by writing a test first and watching it fail, you know the test is valid. So I don't trust a test I've never seen fail. So it could be written in such a way that there's a problem in the test that it will always pass. The code it's trying to test could be broken, and I would know it because my test won't fail. So because I run it first, I know that not only will it fail, it'll fail for the right reason. Usually I have an assertion that I expect, hey, this text is supposed to be on the screen. A calculation is supposed to be in this result. I know that when because there's a data setup issue, and I know that my test is valid because I've seen it fail. This is also especially helpful when you're fixing a bug. So you can know that your fix is correct, and you won't get the ticket reset because you have a test that reproduces exactly that failure. Then you make your code change to fix the bug. You run the test again, and it passes. Then you're good to go. You can then back out your fix, run the thread test first. You only have two, so it saves you some time. Third advantage, it's a lot easier to write code that is testable when you write the test first, because you have to think about the design of your code when you're writing your test, so your code will be more test friendly. If you're writing the test after the fact, it can be painful sometimes to test code changes, depending on how deep. Maybe you have nested code deep inside 4 if statements or something that you have to do all this data setup to get down to what you want to test. You may even have to go and change your code, refactor it after the fact to make it so it can be tested. But if you write your test first, you don't have to worry about any of that. Your code will be a lot easier to test. Number 4, I hinted on this with that refactor step of the red-green refactor loop, but you can help prevent code rot, so tech debt, from getting into your code base. You can stop it before it gets in. It can be hard to sell refactoring to management after the fact, because anytime you change code that is written today, you have a risk of breaking something that already works. And that is a risk that most folks don't want to take. And that's understandable. We generally want to keep moving forward, not go backwards by breaking something that already works. But because one of the outputs of TDD is a huge test suite that is very extensive in its coverage of your application, you can refactor things without having to worry about breaking something that already works. In addition to refactorings, other changes to your code base are also a lot easier and faster. So things like you can respond to your customer if they want functionality to behave differently. Small tweaks to maybe the last minute requirement changes right before release. Hey, we need this to behave a little bit differently. You can make that change without having to worry about breaking functionality that already works because you have this big safety net. You can also make last minute bug fixes as needed. You don't have to push back on folks and say, hey, there's a huge risk if we make this bug fix. You have a nice extensive test suite that will catch any regression errors you introduce when you're fixing a bug. You also have the ability to go in, and we all use different libraries and frameworks to make our job easier, not writing everything from scratch. But it can be risky to update a library. Say you're updating your version of Angular to the next one. We're looking to go from 1.2 to 1.3 right now at my client. And there are times where the framework changes, the APIs they use change, so we don't know what's going to break. But if we have an extensive test suite that verifies our code behaves correctly, especially functional tests, higher level tests, then I know when we upgrade the version of Angular, I'll catch something that breaks. There could also be times where maybe not only an API change, where there are bugs that show up in newer versions of the libraries and frameworks we use, so we can catch not only incompatibilities, but regressions in the libraries that we use. So it can be a lot safer to update libraries and frameworks, and we're not stuck on older versions. I know there's some places, there's a place that's still stuck on an older version of Grails that can't even update from Grails 1.3.7 to 1.3.8. It's just not compatible. and they don't have a test suite to be able to catch those kind of compatibilities. So if we have our large test suite that comes out of TDD, then it's a lot easier to upgrade our libraries and frameworks. And a bonus advantage. So this test suite, in addition to verifying application works, also can be looked at as a set of executable documentation. So there are other ways to document. You can do things like code comments, have an external set of documentation that says how your application is supposed to work. But it's easy for that to become out of date. A lot of times we're making code changes. I'm sure we've all been there. We've seen where a line of code and the comment above it, they say opposite things. And then you get nervous. All right, which one of these is right? Is the comment right? Is the code right? But either way, that doesn't help anybody. That just adds to confusion. So we don't have to rely on code comments and external documentation for a new user to come in and see how this code is supposed to behave. We have tests that demonstrate how it's all supposed to work. And because if we're executing those tests on a regular basis, say every day or every check-in, then that test suite is not going to become out of date, like natural language comments or external documentation would be. All right. Before I move on here, any questions about those advantages of TDD that I listed down?
What are the disadvantages?
It can take a little bit getting used to. So getting started initially can be a little bit slower because it's just a different mindset to test code that doesn't exist yet, especially in a statically typed language. If you start doing, let's say, Java, you're going to get compilation errors, and it just feels your IDE is going to be read from top to bottom because all the classes don't exist in your test. So that can be a little bit of a challenge to get used to.
Do you usually work with teams that all develop in TDD?
No, that's one of the other advantages I'm going to talk about here in a second. Yeah, and yeah, I actually, generally most teams I work with, I'm the only one that does TDD. So but I'm fine as long as other folks are writing tests and all. If they write them afterwards, I'm totally fine with that. If I come to if I run into a lot of instances where there's no tests at all for code, then I have to write sometimes quite a few tests before I can make a change, which can slow things down. But if we're in an environment where everybody's writing tests first or later, then that's not as big of a deal. But if it's a place where people don't write tests at all, some places people are not allowed to write tests, then TDD just wouldn't work in that kind of environment. So I recommend, if you're going to start doing TDD, to make the only change that you're doing the fact you're writing your test first. So what I mean is not picking a new language, not using a new framework, both in the code and in the test. So stick with a place where you're already familiar with the app, you've used the language before. So if you're trying to, when I first started picking up Angular, I wasn't doing TDD because I had to learn how to test Angular initially. So to give yourself a higher chance of success, yeah, I definitely recommend the only switch you make to be the fact you're doing TDD, not with a new language or framework. One of the nice things about starting TDD is, unlike if you're switching to a new language, you don't need to get approval from your team. No architecture review committee has to come in. It's only your personal choice, the fact that you're going to write tests first. So you can be the only person on your team that does TDD, and that doesn't impact the rest of your team. So really, the only thing you need to be able to do to start doing TDD is have a testing framework in place and have the ability to write tests. And sometimes folks say, hey, I don't want to do TDD because I don't like testing. And I have done TDD for quite a while, and I don't like testing after the fact. But writing tests first, I enjoy. So you don't necessarily have to like testing to start doing TDD. But after a while, you may start to see the benefits of doing it, and you actually may start to like testing first. So don't let a dislike of testing stop you from trying to do TDD. One thing that is helpful to do in TDD is you're going to be doing a lot more testing maybe than you're currently doing. So having a data-driven framework is very helpful for writing unit tests. What I mean by that is a framework that allows you to run the same test body with different inputs and outputs. This is a great way to reduce duplication in your tests. And I'm using Spock in some examples I have later. And Spock is a great framework for the JVM that allows you to write data-driven tests. If you don't have this capability, right now I'm using Jasmine to test my Angular apps. And we have a lot of tests that there's only The only difference is their inputs and outputs. There's a lot of duplication there. So if an API changes and I'm testing, I'm going to have a lot of tests to update. But using something like Spock on the back end, then you don't have multiple tests that are calling the method or test in different ways. So you don't have a bunch of spots you have to update. This is keeps your code a lot drier. All right, let's go into some concrete examples here. I'm going to start off with 2 code examples, and these are all written in Groovy. So if you have any questions about the syntax, feel free to let me know. So an example of a bug fix. So here I have a calculator. This calculator class has one method that's supposed to calculate the average of a list of numbers. This calculator is broken. The correct formula for an average is the sum divided by the number of numbers. In this case, it's arbitrary divided by 2. This will work in one case where you pass in a list of 2 numbers. Then you get the right answer. And it just so happens that I have an existing test that does just that. It passes in 2 numbers. So this is the Spock syntax. It's kind of a behavior-driven style syntax where it's a little more wordy for the test name. The nice things about Groovy is you can write strings as method names, which you wouldn't do in production code because that's just weird. But in test code, makes this very readable. So this test is supposed to average out 2 numbers. And Spock segments out the tests into essentially 3 different areas. So under the given block up there is the setup. And then one of the nice things here is this run block is only where I'm calling the method under test. So it makes it really obvious, okay, what code is this method testing? It's less helpful here because it's a pretty small test, but in a big test, sometimes it can be hard to figure out, okay, where's the actual test part happening? And the code under test is called in the when block. And then all my assertions are at the end in this then block. There's only one assertion here, but it could be that maybe I had multiple things I want to test, and those would all go in the then block. So this test is verifying that when I ask for the average of 5 and 15, that it's 10. And that works because my formula works for this one case, but it's broken. So what should I do now? I want to write a new test case that reproduces the bug in the system, which is any list longer or shorter than 2, the average is going to be wrong. So here I have a test that averages 3 numbers out, 3, 6, and 9. And my test is trying to see that the average is going to be 6, but it's not. My code is wrong, so it says that average is 9. So now I have a failing test. I have the red part of my red-green refactor loop. So now I can fix the code. So here's the correct formula. Sum up the numbers and then divide by the number of numbers in the list. So this should be correct. I should run my test and they pass. Yay, they pass now. Yeah.
Well, your test is going to blow up if you pass it on list of 0.
Right. So there are definitely not a perfect. There's some. Yeah, that'd be probably something you'd have to define and say, oh, I'll throw an argument exception there if you expect at least one item in the list. Yeah, that'd be kind of a decision there. Yeah, the method's also not null safe. Pass in null, it's going to throw an NPE. So there are additional test cases that we could add to make it even more robust. So my 2 tests. So now I have my refactor step, which is optional. There isn't necessarily anything I want to clean up in my spread method here, the method that calculates the average, but my test code has 2 tests that are almost the same. So what am I going to do? I'm going to extract them out using my data-driven capabilities of Spock. So here, in the where block in Spock is how you define the different iterations run. So this where block is creating 2 variables, numbers and expected average, and each line under that is going to be an iteration of the test. So here it's going to run the test once where numbers are 5 and 15 and expected average is 10. So then it'll run it for my first iteration, and the second iteration with 3, 6, and 9, and 6. And that add and roll up there is a Spock annotation where it expands the test report so that each one of these looks like its own individual test case. It's not a huge thing, but it makes a test failure a little easier to reason about. So I always throw that on there when I'm using a data-driven test in Spock. But now I have the same test coverage, but a lot less test code because I'm only calling average in one spot. So if the signature to average changes, and a mandatory argument to the constructor to calculator, I only have one spot to change instead of 2. So then I can add more test cases as I see fit under there, and don't have a lot of extra code. All right, any other questions about that bug fix before I move on to an example of a new feature? Right on. So now I want to add a range method to this calculator. So range here is the difference between the smallest number in a list and the largest. So what I'm going to start off with is write some failing tests. And I'm going to write tests for a method that doesn't exist. So here I'm already defining the API for what range is going to do. So I'm going to say range is going to take a list of numbers, just like average did. And I'm going to write two test cases to start off with. One where the range, I expect the range of 1 and 3 to be 2. The other one, I expect the range of 11, 20, and 31 to be 20. So in both cases, those are just the difference between the first and last numbers in the list, so the biggest numbers and the smallest. I'm going to run this thing, and it's going to fail. And the first failure is going to be that that method range does not exist. So this is what a groovy exception will give you if you call a method that doesn't exist with the args that you passed in. I'm going to go ahead and implement the method. So here, I'm going to look for the last number in the list and then subtract the value of the first number. Say, okay, that's going to be my range for the list. My test pass, hey, cool, I'm good. Do I want to move on yet? Are there any additional test cases I could write here? So in my two previous test cases, I passed in lists that were in order. What happens if the list is not in order? It's not sorted. Is my method going to hold up? So I'm going to write a test case, another test case here, and because I'm using a data-driven framework, I just add another line at the bottom of my test. So I'm going to pass in 12, 28, and 15. And the expected range there is 16, difference between 12 and 28. But is that going to work? Another nice thing about Spock is you can include the value of this variable, any one of the variables in your where block, in the method name. So in the test report, I will see if one of these fails, exactly which line failed, because it's going to replace my pound numbers there with the value. So if this last test case I added fails, it's going to say should calculate the range of numbers 12, 28, 15. So I can see right away from the test report which line failed. And that's just it. What's that? In Spock?
Yeah.
It's been around for a little while, but it might be newer than some of the very first versions of Spock. But it's pretty handy. All right, so now I'm going to run this thing. My new test case fails. So my implementation, my range method could use some work. It thinks the range is 3 because my naive implementation is just looking at the first and last and not sorting it. So now I'm going to go back and fix my range method to first sort the numbers. And in the Groovy world, when you call sort by default, it mutates the list. So I don't want to mutate whoever passed in numbers. So I don't want to mess up their list of numbers. So you can pass in false to sort, and then it just creates a new list and doesn't modify the one you're passing in. So then I don't mess up a caller without their knowledge. So I sort the number of lists, sort the numbers, and now when I do first and last, it's going to give me the right answer. So now my test pass. So that's a common thing in TDD. While you can get to green in your feature, you want to think, hey, are there additional cases here I need to handle? Error cases, different ways that the user could pass in could call the method. But the nice thing is once I already have my test suite, it's really easy to add additional test cases to it. I don't have to figure out a new way to test a method. And as now I'm at the refactor step, which here I'm fine with my data-driven test and final implementation. So that's an optional step. I'm gonna skip it and say I'm done with this feature. All right, any questions on that example before I dig into a web application example? All right. So in this one, because a web app would be really heavily tied to a certain framework, and I don't want to get into those nuts and bolts, this will be more of a high-level example just of the steps that I would go through to do TDD of any web app feature. So here I'm going to go through the steps to implement a user registration feature, so where someone can sign up for an app. And as you alluded to earlier, I'm going to run through a couple different loops here, starting off with high-level tests and then moving on to lower-level unit tests. So what that looks like, I'm going to start off with a couple the browser functional tests, and then iterate through between back-end unit integration tests and then my production code. And then once I think I'm done, once all my unit integration tests are passing, then I'll go back up and run that functional test as well, and it should pass. So I'm going to start off with kind of the happy path. I write a browser functional test. It's going to go to this registration page. It's going to enter in an email and password. That'll be one thing I require. Click my button, submit the registration, and then go look in the database, verify that the user record with that email was created. It's kind of at a high level. So when I first run this thing, it's going to fail because I'm going to a page that doesn't exist. But during this part, during the time of writing the test, I've already started to design my code. I have things like I have to know what URL I'm going to go to, so where that URL of that page is going to live. I started to design the form, so I need to know to tell the test how do I find the email and password parts on the form, and what does that submit button look like. So I've already got it, and what is the design of the database going to look like for that last verification. So I've already started to design my production code. But yeah, first off, that page is not going to exist at all, so my test is going to fail for that. So now I'm going to create it, just the skeleton page, so a form that passes in, takes an email and password and passes it to the back end. And I'm going to call a method on the back end that doesn't exist yet. I'll call just register in this case. And now I'm going to start iterating through some back end tests for this register method. So it'd be a test to go in and, oh, sorry, question?
Well, since you're beginning on the front end and then you're testing the back end, that really kind of breaks one of the rules. It should get the verified user exists on anything.
So that's another option. I could include in my test, once they've registered, I take them to the home page, and then it shows, hey, welcome, and then their email address and so forth. So that can be an additional test part to the front end test case that I could add. And this is also, if I was using a framework like Angular or something, I'd also have JavaScript unit tests that covered maybe an Angular controller that does the registration part. So there could be JavaScript front end unit tests as well. So my register method, I'm going to call it with an email and password and verify that a user gets created in the database. So I'm going to run these tests, and they're not going to pass either. They're going to fail because register doesn't exist. So now I've gone through a red loop on the full stack functional tests, and then a red loop on the backend unit tests. So I'm going to go and implement my register method. Nothing fancy, just go and create a user. Run these backend unit tests, and now they pass. So now I can safely go back up the stack and run the full browser functional tests, and it should pass as well. So now I've got an executable set of documentation of how this feature behaves. So what works thus far in the feature is that someone can go in and register with a new email and password. But I'm definitely not done. There are all kinds of different error cases I want to handle here. So I'm going to go through, there's what happens if, say, the user already exists. So I'm going to go and write an additional functional test case for one of these errors. And I don't necessarily need to go and write browser functional tests for every possible error case of registration, because browser functional tests are a lot slower to run than, say, a backend unit test. So I don't want to go too crazy on the number of functional tests I write. But I'm interested in definitely having the happy path where someone can register successfully, and then at least verifying one error case. So if something goes wrong during registration, that the user gets displayed the form again and a correct error message. So in my error case here, I'm going to create a user in the database ahead of time, then go to the registration page, fill out the registration form, but with the same email that I already created. So this user already exists. I don't want to have duplicate users in my system. So here in my functional test, I should get an error message saying, sorry, this user already exists. You got to pick a different email. So I'm going to run this functional test, and it should fail because the registration will succeed, but I'll end up with duplicate users. What I expected was an error message and to stay on the registration form. So I'm going to go in and update the page so that the backend gives me an error message that I display it to the user. And now go and write a failing backend test that's similar to the first test. It registers, but there's a user on the database first, so it should throw an error that user is already there. So now update my backend registration method. So now I should be at the green part of the red-green refactor cycle. So I run that thing, the backend unit test, and it passes. Now I should be able to go and run up the flagpole, run the browser functional test, and that should pass as well. So now my test executable documentation of how this feature works is that a user can register with the new email and password, and that it handles errors. So if the user already exists, it's going to give them an error message. And there are additional errors I probably want to handle as well. Things like an invalid email address. I want to make sure the user doesn't have their password's not 1, 2, 3, 4, 5. Probably could put a regex on there to make sure they have a strong enough password and so forth. And that's an example of what we probably do in our day-to-day jobs of test driving a feature in a web app. Some great resources if you want to learn more about TDD. Kent Beck's book, Test and Develop by Example, is kind of one of the main books on TDD. Its examples are in Java. If you're familiar with Java, it's a little bit older, but it has a lot of good fundamental information about TDD. And when you're first starting TDD, it's helpful to go in very small increments. So in his examples, he goes in much smaller increments than you would in your day-to-day job, but it gets used to writing things in a TDD style where you're not writing extra code. So it's a great starting resource. It's a little bit of a longer book, so if you're interested in a shorter introduction and this behavior-driven development JavaScript, it's a nice short book that I've read recently. It's very, very concise, and it's using the same testing frameworks you'd use today. It uses Karma and Jasmine for testing JavaScript. And it's a nice, concise introduction to BED. It also has a good intro just to specific JavaScript information in it as well. So those are both great things to check out. All right, so summary what we talked about today. If you write your test first with test-driven development, you can get more value out of the same amount of work of writing your automated tests, but it can be less painful than having to write the test after the fact. You can get a lot smoother experience writing them first. And because you don't have to get approval from anyone else, you don't have to get the rest of your team on board with TDD, you can start doing TDD when you go back to work today if you want to. All right, what questions do folks have? Chris.
Your method names were strings for your test?
Yeah.
Is it typical to have all these strings? Or?
In the Groovy world, it is, especially these days with Spock. Back in the day in Java, we would do camel case. So it'd be a little bit harder to read. I would do the same style of a sentence, but do it in camel case, because you can't do strings in Java. But in Groovy and in JavaScript as well, because then with things like Jasmine, your method names or your test names are strings. It's pretty common to do in both Groovy and JavaScript.
So that kind of takes place in having comments.
Yeah, in general, especially if you have a nice descriptive name there. In Spock, you can also have a string after the given, when, or then labels. If you want to just call out explicitly, hey, my setup does this, or my when I'm calling the method does that. Those are options as well. But a lot of times I only have the method name and I don't need any additional comments. Versus the olden days, we might do things like my test method is called test1 or something like that. And then you got a big comment above explaining what's going on. And that, just like source code comments can get stale. But here the method name it kind of replaces that. Other questions? Yeah.
So do you have any idea, is there any way for you to ballpark what reduction in technical debt you're getting?
That's a good question.
That's a huge thing.
Yeah, so that's unfortunately, I don't personally have there haven't been any widely available studies on that. I know I've worked with folks in the past who have introduced TDD in places on kind of a project that's one project using TDD and one that's not, and they've had a substantial decrease in the number of bugs that have come out of it. But as far as tech debt, that's another thing that could potentially be reduced a lot. All right, anything else? Yeah.
Process of testing. So I've seen some people doing it like you do one line or just enough to make it pass and then keep going back forward. It's not clear to people who have steps. Do you write that out at the same time or are you using the same?
That's a great question. And especially in Kent Beck's book, he goes very small steps. So it'd be like if he wrote out that range method, the first time he called it, it would just return the hard-coded value of 2. And then you build that up. When I first started doing TDD, when I kind of learned on my own, I would do that way as practice. But now to speed things up, I write generally 3 or 4 test cases and then just go ahead and write the method and then go the full implementation, at least what I think it is, and then go back and see if there's additional test cases I can write. But I generally have gone away from the very small iterations. But if you're learning how to do it, that can be very good practice. So one of the advantages of TDD, one of the things it tries to do is to get you to avoid writing a bunch of extra code that's not tested that you think you might need in the future. So that can be another way to introduce tech debt, is trying to help yourself in the future and end up hurting yourself by writing code you don't need and is not covered by tests. So by writing in very small iterations, and you know that I'm not writing extra code that's not covered, but this way it's a little bit faster in my day-to-day job. All right. Well, thank you all for coming.
Sure.